Welcome to this tutorial on MathPiper for beginners. As you see in this agenda, in this video we'll walk through what you need to know to get started using MathPiper, including walking through the MathPiper IDE interface, using the console, some of the various plugins that come with MathPiper IDE, and spending some time going through how to make and use a MathPiper worksheet. Then we'll talk about how to do some of the basic mathematical operations and how to do some more complex actions using MathPiper's built-in functions. Then we'll get into some of the more general programming functionality of MathPiper, including making lists, assigning data to variables, using strings, that is to say plain text, how to get user input, which comes in as a string, and we'll talk about how to get that user input and convert it to a number. We'll define our own functions, do conditional, which is to say if-then statements, and then a couple of different types of loops. Timestamps are in the description, so let's jump right in. As you'll see, I have up the MathPiper IDE. This is free and can be downloaded directly from the MathPiper website, the link to which is in the description. When you open it up, there will probably be a few different panes you see right away, so the first thing you want to do is close out of everything and just make a new, fresh MathPiper worksheet that we'll be using for most of the tutorial. So if you have a pane in the far right side for charts and graphs, that might look like this. Let me just pull it out. So you might have something that looks like this. You can just close out of that with this red X, or you might have your sidekick open, so it might look like this. You can just close out of it with the red X. We will get into that a little bit, but you don't need it for right now. You'll also see that I have this agenda up. This is not actually in a MathPiper worksheet. This is just kind of a plain text document. But don't worry, we'll make a MathPiper worksheet soon. But first, let's go ahead and take a quick tour of what the other items are in this MathPiper IDE that you might find useful. One very useful item in the MathPiper IDE is your console. You can click this button that says MathPiper Console at the bottom here. Just to bring it up, to change its position, you can click this arrow. To make it dock at the top or left or right or what have you, you can undock it to make it float around. You can make it bigger and smaller. You can also zoom in and zoom out. I'm fairly zoomed in here. And the way that the MathPiper console works is that you can just type in whatever you want to evaluate and hit enter or return on a Mac, and it will evaluate it for you. So it's pretty good for just a quick reference. So if you just type in 2 plus 2, for example, and hit enter, it'll tell you, hey, I can do that, it's 4, okay? And if you check this box for LaTeX result, it will print it out in a nicer looking format. So if you do 2 plus 2 and now you see it prints it out, it's a 4. Notice the difference. It went from this kind of, just a plain texty 4 to, a LaTeX formatted 4. That's in a nicer format. You can really see this if you do something like a square root. So for example, in MathPiper, if you do square root of 5, which is capital S, QRT, with parentheses 5, this is what's called a function, which we'll get into later in the tutorial. MathPiper does not change this to a decimal like your calculator might. It's just going to, by default, keep it in a symbolic form. So if this is not checked, it's just going to keep it in this plain text format. But if the LaTeX result is checked, then you see it prints it out with a nice radical symbol. Radical 5 looks great. Okay, but let's just uncheck it for now. All right, so what if you did not know offhand that this was how you did square root of 5? This was the function for square root. You don't need to memorize it. It's right here under Docs. You just click Docs, and that's the documentation for MathPiper. And so you can just search with the search bar here and just type in kind of a plain text search of what you want, square root, and you see there's some options. But what we want is the square root. And there it has it right there, SQRT, parentheses with x being the argument, which is another way of saying what you put inside the parentheses, and that just shows you what the format is. Once we get to the worksheet, we'll see that expressions there in the worksheet are going to need a semicolon at the end to be evaluated. Here in the console, there's no need for that. You see I'm not using semicolons at the end when I type 2 plus 2. But if you get used to using the semicolons, it'll still work just fine if you have the semicolon in there. And if you want to suppress the output for whatever reason, 2 plus 2, if you do 2 semicolons, you see it'll just say output suppressed. It'll suppress the output, which could be useful if you don't want the result to say anything, if it would be some long result that you don't actually need because you're doing something else with it. You can just suppress the output with 2 semicolons. All right, so the next thing I want to show you on our tour of the MathPiper IDE are the plugins. So let's go ahead and close out of the console by hitting this X. And the plugins are in this menu that says plugins, and I just want to show you where these are. You'll see that there's a variety of plugins that come with MathPiper. One that we saw already is the console. There's some others. There's a quick notepad if you want to just take some notes. So if you click quick notepad, it'll pop up with, a nice notepad and you can take some notes. Or you have GeoGebra, which I'm not going to get into in this video, but is a fairly popular open source geometry and algebra application. And to find that, I believe it's under Dynamic Math. Yes, so Dynamic Math and then GeoGebra, and you can go to that application. And there's also just like a regular calculator. I think it's just a regular scientific calculator. So, there's different things. So those are just some of the items that MathPiper IDE has to offer. But as mentioned earlier, for the bulk of this tutorial, we will be working in a MathPiper worksheet. So let's go ahead and make a new worksheet. This is tricky because you don't just go to File, then New, because that's not going to make a new worksheet. It's going to make this text file of the kind that we made our agenda in, and it's not going to be able to do anything that I'm about to show you. So you just click File, New, and then you save it as a worksheet. So you just go File, New, okay, or you can hit this this blank or hit Control N, and so File, New, and now we're in this kind of text document, right? Then you click File, Save As, and then you give it your title, Piper Tutorial 1 or whatever, and then dot, okay, this is important, dot MPWS, MathPiper Worksheet. You give it the extension name when you save it as dot MPWS. M is in MathPiper, MPWS. That's the most critical thing, because then when you hit save, now it's a MathPiper worksheet, okay? And now we have a MathPiper worksheet. And the way that MathPiper worksheets work, it's kind of like a Jupyter notebook. You section off pieces of the worksheet called folds, and each fold is kind of like a cell in a Jupyter notebook, if you're familiar with that, except you have to make it yourself. And you can do that by right-clicking and clicking Insert MathPiper Fold, and you'll see what I mean. When you right-click, you click Insert MathPiper Fold, it makes this kind of section, okay, that starts with a header, ends with a footer, and this fold, inside the fold is where you're going to do all of your work, okay? And you can make a bunch of them, but anything that's between these folds, okay, isn't going to be amounting to anything, all right? You need to do all of your work inside of a given fold, okay? And so you see you have your fold. That's the space in between this top text and this bottom text. And what MathPiper can do is evaluate whatever math you put inside of this fold. But critically important, you have to put a semicolon at the end of your line. Otherwise, MathPiper is not going to know that you're done with the expression. If you're coming from a Python background and you're used to going to the next line, the next line, the next line, that's not going to work. MathPiper is not going to know that you moved to a different line. You need the semicolon, and that's what indicates to MathPiper that you're done with that line. So if you put 2 plus 2 semicolon, okay, critically important, that semicolon, then you can just run the MathPiper fold, and you can do that on your computer by hitting Shift-Enter or Shift-Return if you're on a Mac. So let's do that. If your cursor is inside the MathPiper fold that you want to run, Shift-Enter, that runs it, and there we have it, our result of 4. Okay, 2 plus 2 semicolon, we ran it, okay, result of 4. And notice that the output that you got is also inside of a fold, inside of this output fold, right? Because you have the percent output, percent slash output, the header and the footer to the fold, okay? So that's actually important. Also notice that it's indented. That's because your first fold here, okay, this fold is your parent fold. This output is your child fold, okay? You can think of the output as depending on whatever's inside the parent here. Also notice that there's this property in this fold here, preserve equals false. That means that the fold is unpreserved. So if we were to run it a second time, if we were to run the parent a second time, it does not preserve this output fold. It's going to get rid of it and remake it afresh with something new. So for example, it was 2 plus 3 instead, and we ran it. This is not a preserved fold, okay? It got rid of the one that said 4 and put in a brand new one that said 5. That's usually what you want, but you can preserve it instead, okay? If you want it to stay there, you change preserve to true, and then when you run it, say you do 2 plus 7 or something, now this one that was a preserved fold, because preserve is set to true, your result of 5 stays. It didn't go anywhere, and it just made a new fold. The new one is also unpreserved. So if you ran it again, see, it reran this, but it kept this one. So one way to quickly clear out all of your outputs is going to be a shortcut to remove all unpreserved folds, because by default, right, usually this will be false. So, what you can do if this was false, you right click and you click remove unpreserved folds, and that'll just wipe out your output, right? But if this one had been true, and say we have another one that's false, if you remove unpreserved folds, the one that's true, it's preserved, it's going to stay there, okay? But normally we'll almost always keep the output as unpreserved, and you'll see me from time to time just remove unpreserved folds just to clean up our worksheet. Okay. Other things with folds, notice that you can give your fold a title. So if we have our new fold here, okay, and we can just even make another one. Actually, let's just delete everything. Let's make a new fold, and we can give it a title. That'll be useful to someone reading it or someone looking at the outline of it later. You see how right now it's MathPiper title equals, kind of blank. But if you have a bunch of folds, then it's not going to be as helpful if you don't have titles. So you'd certainly feel free to add titles. It won't impact the functionality. So if you make your title 2 plus 2, but then inside the fold you're doing 2 plus 3, it's just going to give you 2 plus 3, right? So the title's more for you. But we can say like, okay, 2 plus 3 or whatever. And then if you do that, 2 plus 3 semicolon, and you run it, and your result's 5, and now you have, see, a nice outline where it says, okay, well, see, now I know where my 2 plus 3 is in this fold. Okay. Anything that's outside the folds you can't run on the worksheet, so you could also put kind of a description or your notes between folds. So if you have a couple of folds, right, let's just add a few folds. You could also put, this is my cool fold below, check it out, or whatever, and that's not going to impact anything, right? If you do 2 plus 2, it'll be fine. Okay, but you could also put what's called a comment inside a fold. You can precede it with 2 slashes all on one line and say, see, it's really cool. And that's like my comment to this, right? Your comment is just text for the human reader. Doesn't matter what it says. In terms of your program, it won't matter. But it's useful if you want to comment out something, so you don't want this to run at the 2 plus 2. You can just do // and that'll turn this into a comment, so the computer won't read it. Only a human would read it. And you can also add a bigger comment across, across stretches of lines with the symbol slash star, and then, you would say, this is my program, it's really nice. I want to thank the Academy, whatever. And then you just end it with star slash, and it's going to run the 2 plus 2 as 4 and ignore all this because this is just for the human reader. So one more issue with folds. Let's just delete everything. Your output is only going to read the last expression. It's only going to evaluate and spit out in your output automatically the last expression. Again, kind of like a Jupyter Notebook cell, if you're familiar with that. If you're not, no worries. But if we put 2 plus 2 semicolon and then 6 minus 3 semicolon, it's only going to give you the 3. You see? It doesn't give you in your result here also the 2 plus 2. It's not displayed. So one way to get everything, all of your different lines to display is to use a function called echo. And that's echo with a capital E, parentheses, and then whatever you want to evaluate inside the parentheses, and then you end everything, as always, with your semicolon. So if we just put in the top expression in echo and keep the bottom expression on the bottom and run it, you see the side effects are what comes from echo. That's the 2 plus 2. The side effect comes from echo. The result is your output from your last line. So if you made this one echo as well, it's just going to give you both inside your side effects, and result true is just saying, basically saying it evaluated the expression. Okay, so you're no longer getting anything inside the result. You're getting these both inside effects just from echo. All right, so notice also that it prints these on new lines. So the 4 and then a new line, the 3 in your side effects. That's not tied to the fact that we made it on a new line. What matters is the semicolons. The semicolon is what matters. So if these were both on the same line with semicolons, it'll be the same exact thing, okay? Or it can be, all the way down here, right? It'll be the same exact thing, okay? It doesn't matter. Also, if you have a really long worksheet like this, you can review, you can split it horizontally or vertically. So if you split it, this is actually just splitting the same worksheet. So you can look at one part of the worksheet up here, the other part down here. Just be careful, because if you X out of it, that'll close both of them. So you don't X out of it when you split screen. You gotta go back up here and unsplit it. All right, so that's fine. And if you want a space between these things, you can. Let's clear out some of this nonsense. Okay, if you want a new space between these things, you can. You can just make it blank, and just echo to nothing, and it'll give you that blank space. So you can certainly also do a blank space. It's fine. Just don't forget your semicolons. All right, so now that we have the gist of how the MathPiper IDE works, let's jump in and do some math. And let's start with our basic mathematical operations. These are not so unexpected. Just to save time, I'll copy paste them from my other monitor and we'll walk through them. Let's clear our outputs. Okay, so as you can see, for addition, we have the plus sign, subtraction is the minus sign, division is this dividing sign, and exponentiation raised to the power of is a caret. Okay, it's like the shift 6 caret. One note, when we evaluate this, pay close attention to what happens to this 3 over 4. The answer might surprise you. Okay, so we have it added, it subtracted, it raised to a power. The 3/4, though, it kept it as 3/4. What happened here, MathPiper by default is always going to try to preserve things, like preserve fractions as fractions, not change them into decimals. It'll try to preserve square roots as their symbolic form. That's just the default. If you want this to be a decimal instead, it's no problem. There's just one more function you need to know, and that's capital N as in Nancy, M as in Mary, okay, NM, and you wrap that inside parentheses, so you have echo, and then you inside these parentheses, uh, and then N, M, N as in Nancy, M as in Mary, capitalized, and then when you run that, now it gives you 0.75 because it changed it to a number from a fraction. Okay, so these will follow the classic, PEMDAS, please excuse my dear Aunt Sally, order of operations that you probably have learned or might be familiar with if you have them together. So, parentheses, exponents, and then multiplication or division, then addition or subtraction. So if you have a whole expression in here, if your expression is, echo, whatever, 3 minus 2 times 12, semicolon, and then echo, let's put the 3 minus 2 in parentheses, and then times 12, and then you run it. You see it gives you two completely different results because the first one is taking 2 times 12 first, 24, and then 3 minus 24 to get your negative 21. The second one does the parentheses first, 3 minus 2 is 1, 1 times 12 is 12, so that's just something to keep in mind when you're evaluating longer expressions within this echo function. All right, so these operations are all well and good, but for most of what we will be doing, we will need to use functions. So the next thing that I want to talk about are functions and how they work in a little more detail. We've seen a couple already. We saw the square root back when we were working with the console. We've been using echo now for a little while. In the programming world, function has a little bit of a different meaning than it does in mathematics. In programming, a function is some pre-written bit of code that you can use to perform a certain task. And in MathPiper, functions are designated by some keyword followed by parentheses. Okay, so just like this echo is a keyword followed by parentheses. Okay, so like so. And then whatever's inside that function is called the argument, all right? And so, for example, if you do echo of 4, that's the argument. That's whatever you're putting, that's the, whatever you're putting inside the parentheses for the function to do something on, to, evaluate. And when you run it, okay, it gave you that 4, because that was the argument inside the echo. So, for example, if you wanted to find the factorial of the number 5, right? So say, let me just clear this out. Say you wanted to find the factorial of the number 5. Well, you could do, the 5 times 4 times 3 times 2 times 1, right? That'll work. It'll give you 120. But why do that when you can have a function do it instead, right? If you wrote that out, I mean, maybe you would make a mistake. It's very tedious. It's very, menial to do that. And what if someone had asked you for a much bigger number that you couldn't do that if you wanted to, right? Even doing that for a 9 or a 10 would be very, very tedious. And so MathPiper has a function that can take the factorial of a number, and it happens to be called factorial, capital F, factorial. Okay, and then you just put whatever you want inside the parentheses, right? So factorial of 5, and there it is, 120, right? Factorial of, these numbers can get pretty big pretty fast, but let's do 11, and you see, and it'll do it for you, okay? What the 120 is, or what have you, or this number, that's just the output from what was being evaluated. What's important for you is that it's the factorial, it's the name of the function, parentheses, and inside the parentheses is the argument, in this case, the 11. So that's all well and good, but do you see a problem? How are we going to just memorize that this is the function to take a factorial? And what if we want to do some other different mathematical operation and didn't know offhand what the function was that could do it? I mean, do you have to memorize every function in the book? Well, the good news is that no, you don't. Right here in the MathPiper IDE, we have all of the functions listed out in what's called the documentation. So if just like we found the square root, let's do a different one, and we can see, for example, how we take the absolute value of the number. So you go to MathPiper Docs here on your sidebar, click that. All right, and you'll have under procedures, okay, or search. So let's start with procedures. You see there's a list of all procedures, and these are all the different procedures that you can do. And they also split them between programming and mathematics as well. But absolute value, if you're just scrolling, you can see that it's here, ABS. Or you can search. If you search for absolute value, you'll find it. ABS, absolute value of a complex absolute value or modulus of a number of a complex number, but of course it doesn't have to be listed as a complex number. So okay, so ABS parentheses, X is the argument, all right? So all you do, you take a look, you see what it is, and you say, okay, so ABS, absolute value of, -9 is 9, all right? And you can even do it with an echo if you want. Works just fine, okay? See, you can do the echo of a function. Just wrap it and wrap it, okay? So procedures is good if you wanted to browse the list of functions available. Search is good if you have something in mind and you want to just type it in and see what it is. All right, so you can also feed a whole expression. So let's close out of this. If you wanted to, you can do, -9 plus 8 times -18. I don't know, I'm just making stuff up. But you can do a whole expression, and it will give you the absolute value of that expression. So what does it do? First, it takes this expression. It does this in the order of operations. Then it takes the absolute value, and then echo tells you to print it under side effects. Sometimes functions take one argument, as we've been seeing, even though, this seems like it's a lot of different things. It's actually only one argument. It's only one expression inside the absolute value. So sometimes functions like this absolute value will take only one argument. Sometimes they will take multiple arguments separated by commas. And sometimes functions do different things if they're given one argument or two. So for example, if you wanted to generate a random integer, there's a function called random integer. Okay, note the capital R, the capital I. Okay, and if you only type in one argument, say 100, then this 100 is going to act as the upper bound, and it's going to generate a random integer between 1 and 100 inclusive. See, result 88. If I ran it again, result 45. If you make it 3 instead, it's going to give you between 1 and 3 inclusive, right? Let's just keep going until we get 3. There we go. So you see it also includes the 3. All right. But what happens if I type in 2 arguments separated by commas? What if instead of 3 you have 25, 30? Now we're no longer starting at 1. Instead, we're going to generate a random integer between 25 and 30, once again inclusive. So see, 27, 30, 29, it's giving you a random integer between 25 and 30. And if you wanted to do a bunch of these, you can do a bunch of these, right? Echo. And just copy it and paste it. And now it's going to generate, a bunch of random integers between 25 and 30. Okay. So one more thing that we can do, actually, no, never mind. Actually, yeah, I'll show you. So one more thing, if, again, I don't want to beat this dead horse, but if you didn't know that this was random integer, you can go to MathPiper Docs, you can search, for random integer or whatever, random, search some keywords, look at it, see, okay, it generates a random integer. If it's only one argument, it'll do an upper bound. If it's 2 arguments, it'll do a lower bound, comma, upper bound. It just tells you. So, you don't need to memorize much of anything, especially with regards to all of these kind of, functions. You don't need to memorize that random integer happens to be random integer as opposed to randint or whatever. You could just look it up. So that's the point I just want to, I want you to know the syntax, but also know you can look it up. Okay? So that's a very important skill for using MathPiper, and programming in general. All right. So that's functions. The next thing I want to show you is lists. Organizing data into lists can be a very powerful tool. To make a list, you use brackets, okay, like so, like these brackets, and your data is then separated by commas. And a number of functions will actually only work in MathPiper if you feed them data in the form of a list. And the documentation will tell you so if that's so. So let's look at an example of one. Let's do mean, which is the average. If you go to the MathPiper docs and searched mean, you would see that it would tell you the parameters. It takes a list of values. What does that mean? You have to put whatever's inside these parentheses in the format of a list with these brackets, okay? So if you do mean of like 4, 6, 7, 0, 20, negative 918, notice this is all one argument. This list of values is actually just one argument, okay? It's one list. Think of it like a unit, okay, by making this list of values within these brackets. So it's a little confusing, but mean is the function. These opening parentheses are just what's in any function. It's just telling you, hey, this is what's going to go inside the function. So what's going inside these parentheses. The bracket is showing, hey, this is going to be a list. Then this list of values is the list of values which we're going to take the average of, take the mean of. And when you run it, notice one thing. You'll notice something interesting. When we run it, it gives you this totally useless fraction. Okay, why does it do that? Because, as before, it's going to keep things in a fractional format if it can. It's not going to convert it to a decimal unless it has to. Here, it's perfectly capable of making this a fraction, and so it will. Normally, when you want the mean of something, you want to take the average and kind of have a sense of it, and so you would a decimal value is much more useful. So nm, as we saw before, the nm, if you wrap it in that, that's going to tell MathPiper, hey, don't keep this a fraction, make this a decimal value, and it will. And it shows you, okay, the mean is negative 146.833 repeating, much more useful. All right. And so that's a list. You'll see there's a bunch of different, if you ever encounter, hey, you need to input as your parameter a list of values, that's all that means. So mean is one. There's a few others that are like that. You'll see them going forward. And also, lists are just very useful later and in programming in general. So you'll see these pop up from time to time, but that's the basic concept. The next concept I'd like to go through is making and storing data inside variables. Okay, so a variable is a very powerful tool that can be used to store different data. It can store numbers, texts, even lists can be stored inside a variable. And the way it works is you come up with the name of your variable. It can be any name, though it can't start with a number, it can't have spaces, and ideally it would be somewhat descriptive. But let's just make a basic variable and call it num, short for number, and let's assign to that variable some value using a walrus operator, which is a colon and an equal sign. And so num walrus to show. Whoops, I made a little face. Let's colon and equal sign. Okay, so num walrus 8 and semicolon. And what is that doing? That is telling you, hey, we're going to store the number 8 inside this variable num. So later when we want to do like 4 plus num, it's going to know actually we're doing 4 plus 8, right? So if you do that, okay, you'll see it gives you a result of 8. That's just because it's giving you the output of whatever happened to be the last thing. But if you do like, num if you're storing 8 inside num and then do some other thing and gives you the result 4, doesn't matter. It's still going to have stored num inside 8 inside this variable num. So let's see it in action. You can use it inside the same fold, in a different fold, in the console, universally. Now, whenever I use the word num, it's going to mean 8. So if you do num plus 7, it's actually going to make it 8 plus 7, okay? Or if you do, echo num plus 3, right? And echo num minus num, right? You see, it gives you 8 plus 3, 8 minus 8, because it's storing the 8 inside num. So, as mentioned before, oh, and you can change what's stored inside the variable, no problem. After you do all this, if you do, num uh, walrus colon equals sign walrus, the 4 or whatever, and then echo num plus 0, just to show you. Now, what does it do? Well, it knows that num is 8 here, right? Because before it was 8, it's just going to take it from top to bottom. So it had 11, and then, it's going to be 0 no matter what. But you see how it's 8 here, because 8 plus 3, 8, 9, 10, 11. But then below, after we changed it, now it's changed, and now num is 4. And even if you were to do, in your console, you see it's still 4. Okay, it's universal. All right. So as mentioned, you can do a list inside a variable too. So if you do my list, if you make a variable, let's just call it my list colon equals, and then just some list, whatever, 9, negative 19, 3, 2, 3, 4, 20, 19, whatever it is, okay? And you see now you've stored inside this variable my list this whole list. And let's just show you how powerful this can be. And I have something to copy paste in, and we'll just walk through it. So now, if you wanted to, you can do the mean of, instead of putting in this whole list every time, you can do the mean. There's other, these are just a couple examples of other functions that take lists. So one is maximum, which is going to give you the biggest value. The GCD is going to give you the greatest common divisor on your list. You can just have all this just storing the variable. You don't have to retype the list every time. When we run it, now it's going to give you, hey, here's the mean of the list. Here's the maximum, which is 20. Okay, that's the highest number on the list. And 1 is the greatest common divisor. Okay, so you can change it. You don't have to rewrite everything. You can just change the list if you want to redo this with a different variable, with a different list of values. So if you want to do 21, 56, and 1974, whoops, that was okay, so 21, 56, and 1974. So then it gives you, it gives you the average. And notice I use the NM here to convert it to a number. Just like we did before, the maximum is, of course, the biggest number. And the greatest common divisor of these three is 7. So you see, everything changes with it because there's new data stored in the same variable that was before, but now it has new data, so it's going to change your outputs. All right, so we've been largely talking numbers, but MathPiper can also use plain text type of data called a string. A string is written in quotation marks. Okay, so let's go ahead and clear this out. A classic example of a string would be hello world. Okay, so this is a string, and you see I have it inside echo, so it's going to just print it out under our side effects. And that's kind of a classic first program in any language, including, in this case, MathPiper. hello world inside the string. It's just the plain text. So, the computer is just going to treat it as text. So even if you have a number, for example, inside quotation marks, it's going to be treated differently, and we'll see that. But first, let's show you can add strings together. So if you just do this, like hello plus world, notice I added the space because it's just gonna, it's not gonna do that automatically. It'll give you hello world, right? Or even if you have like 2 plus 2, okay, so it's not gonna give you 4 because it's not a number. It's a string. It's text. It's just gonna smoosh them together just like we did before with hello world and give you 22, okay? Because 2 in quotes plus 2 in quotes is actually going to give you this 22 because it's just saying, first thing and then plus 2, like it's just smushing them together, right? So that's all it's doing. So that's why be careful when you're dealing with strings and you think you have a number, not treating it like a number, just treating it like it's text. All right. So just like with numbers, and lists, you can store strings inside variables, no problem. My string, walrus, uh, you know, hello world. Okay, so my string, I'm assigning it colon equals hello world, semicolon, echo my string, and it's gonna evaluate that, no problem, hello world. Okay, so there it is. One nice thing about strings is that now that we have strings, we can use them to label our side effects outputs from our echo functions. So remember before when we had like, some list of values and we had, I'm just gonna make it up. And then remember, I'll copy paste it back in. We had, actually no, I'll copy paste this other thing in. Remember we had like the mean, the maximum, the GCD. Well, what if instead you had this, where echo and then a string of explaining the mean of the list is this, the maximum list is this, maximum my list, the greatest common divisor is greatest common divisor. Now, when we run it, probably because I was copy pasting it, I'm sure I made some errors, so let me see. Oh, echo mean of the list is, yeah, I just had a misplaced parentheses there. So anyway, so you see my list, you stored inside the list, and then echo, quote, mean of the list is, and that's your string, don't forget the space, comma, okay, to show, hey, this is the first part of what we're printing in our echo, then we're going to move on to the second part, which is the second argument. Echo can take multiple arguments separated by commas like this. And then the next part is going to be the number of the mean of my list, okay? And then don't forget to end with a semicolon. Don't forget to have the right number of parentheses, so everything's closed in. And then you do the same thing, maximum, greatest common divisor, and when we run it, see this? It's so much better. Before, you had to kind of go back and say, okay, what was the first line? What was the second line? Now, because you're using strings, under side effects, you can just label it. So there it is. Mean of the list, maximum, greatest common divisor, tells you exactly what it is. Okay. So the next thing we're going to talk about is getting user input. Sometimes you're going to want to get your, input from your user and store that input into some variable for later. And MathPiper allows you to do this with a function called askUser. So let's clear all this out and let's insert a fold. And let's go ahead and make a variable. Let's call it name. And then walrus to assign it some value. And then ask user, capital A for ask, capital U, all one word, ask user, parentheses. And inside the parentheses, some prompt that your user is going to see. Let's go with, what is your name? Don't forget the semicolon. And then let's go ahead and have the program greet the user. So we'll have it then go echo, hi there. Yeah, actually. Okay, so it's going to have the string. Okay, so that's why it's important to know you have your string first, hi there, and then comma for the next argument, and then whatever it's going to print next, which is just going to be the variable name, which is what your user is going to put in. Let's see it in action. So when we run it, Shift Enter to run, see message from MathPiper. What is your name? And then you type in your name. Okay, and then you hit OK, and it'll greet you. Hi there. And so you see when you run it, and that's kind of how you can start you can use MathPiper to make like an old school text-based adventure game, which is kind of what I'm referencing here. And so it stored that data, whatever the user typed, as a string inside this variable called name, and it stored it as a string, and then it printed it out. It's stored as a string. That's important. If you need to get a number from your user, you can use the same process, but you need to later program in some conversion from the string to a number later. So for example, if you have a variable called num, and then you make that ask user, what is your favorite number? Okay, that's not gonna, if later you want to do like, you know, echo your favorite number plus one is, and then num plus one, right? Um, that's not going to work because this is putting it in as a string. Remember, if you put in 1 here, it's going to print out an 11 because remember before we saw with strings, the 1 plus 1, if 1's a string, it's not going to work. Actually, I don't think it'll give you an 11. I think it'll just give you an error. But anyway, we're not going to try it. Instead, what you need to do is you need to do string to number and wrap it up in that. Okay. And now it's going to prompt the user, what's your favorite number? You give it the favorite number. It's going to convert whatever you gave it, that string, to a number, store that number inside the variable num, and then it's going to print out your favorite number plus 1 is, whatever you gave it plus 1. So let's run it. What's your favorite number? Let's go with 42. And your favorite number plus 1 is 43. Okay. So that's how you get input from a user, convert it to a number. The next thing I want to cover is writing your own function. We saw earlier in the video that there are a number of built-in functions, words with parentheses after them that do some task. We've been using them this whole time. We can make our own by defining our own functions, and you can do it in a way that's fairly similar to defining variables. Let's say I wanted a function that will add 2 plus 2 every time I do what's called calling it, every time I put that function in, every time I call that function. So what you can do is you can call it t and do a lowercase letter 2 plus 2 parentheses, okay? And notice the lowercase letter. By convention in MathPiper, a user-defined function starts with a lowercase letter, which distinguishes it from the built-in functions we've been seeing. Those all start with an uppercase letter. That's just a convention. It'll still work otherwise, but you should try to, if you're making your own function, start with a lowercase letter so people, using your program don't get confused. All right, then you can use your walrus operator to assign it, and then 2 plus 2 semicolon. Okay, so now that defines the function, and if we want to use it later, you can just take some argument and add 2 to that argument. I'm sorry, no, this is just going to add 2 plus 2. You can just do 2. You can just do echo 2 plus 2. Notice there's no argument. I'm just making it a very basic function. Okay, you see, you've made your function 2 plus 2, and you called it, and it gave you 4. It added 2 plus 2. It'll even be in the console. It'll be everywhere. Right, 4. but that's not a very useful function because how often do you need to um, do 2 plus 2? A more useful function would be to take any value that you want to feed into it and add any argument and then add 2 to that argument. So let's make a new and different function and let's call it just plus 2. And let's do this. Let's do plus 2x, and that x is our way of telling MathPiper, hey, this is going to take one argument, okay? And let's assign it x plus 2. And now you see when we run it, this is now going to have, we've now created a function called plus 2. What does the function do? It takes our argument and it adds 2 to it. So now, in our console, later on in the worksheet and where we want, if we want to do plus 2 of, 6, it took that argument, it added 8 to it, right? Still works. Another fold, if you want to do plus 2 of, 5 or what have you, 7, it took our argument, it added 2 to it. This is now a function just like any other function we have in our MathPiper IDE, all those built-in ones. This one works just as well. It's global. Okay. So that's how you make a function. It's a very basic way to do it. And it gave, it's not bad. It's just like assigning a variable, assigning a function. All right. The next thing I want to talk about is conditional, that is to say, if-then statements. Oftentimes when writing a program, you want the computer to make some decision and do something different based on the data that it's given. So say you had a variable and we wanted our function, our program, to do something different depending on what the value of that variable was. So let's make a fold, and let's say we have num is equal to 5. Okay, so say our variable num is assigned the value 5. Okay, so now if we were to ask a question, does this variable num equal 5? The answer it gives us would be true. That's like, it would be like saying, yes, it does equal 5. If we asked the computer, does num equal 7? It would give us the answer false because it doesn't equal 7, it equals 5. And that true or false property, we can use that to our advantage. The computer's ability to say something is true or something is false to guide the computer to make decisions. We can tell it to do certain things if our statement is true, do other different things if our statement is false. And one way to do that is with the function if. Okay, that's a capital I, if. Okay, the if function is a little tricky. It takes an argument inside the parentheses and will evaluate whether or not it's true. So what you put inside the parentheses is called the predicate. It's asking if your predicate is true. So the way you ask it is num equals question mark 5. And that's asking, hey, is num equal to 5? Is this a true statement? All right. And notice the question mark. That's our way of saying, is this true? If both sides of this equals question mark operator are the same, then yes, it is true. If they're different, then no, it's not true, it's false. Okay? Then you need to tell it what to do if your predicate is, in fact, true. And so the way you do that, you use curly brackets, no space, curly brackets, and then just whatever it is you wanted to do if it's true. So that variable equals 5. Okay, and then you close it off with your curly brackets, semicolon. Actually, there we go. So the semicolon's a little tricky. You do the if statement, the predicate, the echo, okay, and then at the end of your echo, you have a semicolon because you can actually have multiple lines here. So you have your parentheses to close off your echo function, semicolon. Then you could do even more stuff, but we're just gonna do one thing. And then at the end of your curly bracket, that takes one last semicolon to end the whole thing. All right. So don't forget your semicolons. Let's run it. And you see that variable equals 5 because it's true. What if it didn't? what's going to happen? Nothing. Results false, okay, because it is false, and it does not print this out. It will only print this out if it's true, right? Okay. So you don't have to make this all one line. Remember, what matters is the semicolon. So, you certainly feel free to bring this onto multiple lines. You can even make the semicolons, and this might even make it easier to see what's going on here. Let's just go ahead and make it do a couple of things. So now, if this is true, so what are we asking? We're asking if this is a true statement, then do all of these things. Notice the semicolons at the end of each of these, and then one semicolon at the end. That variable was 5. Great job. You see, it says all that. So now what if you wanted your expression to do something different? If your predicate was false, that's where another keyword comes in, else. So here's the tricky thing. Before this last semicolon, you put in else. It's not separated by another semicolon. It's all part of these bracketed statements. So before this, you put in an else. And this could be all one line or multiple lines, however you want. The semicolons are what matters. Else, okay, curly bracket, and then, echo, oh, it's not 5. Echo, too bad, whatever you want. And so now, if this is a true statement, it's going to give you this. If it's a false statement, it's going to give you this. So if we run it, you see it is going to be true, so it'll give you this error. And it gave us this error because we didn't close off our curly bracket with another semicolon. So let's try that again. Okay, so you see how finicky it is. You need another curly bracket, semicolon at the end to show, hey, we're done with our else statement as well. So it's true. The variable was 5. Good job. And what if if it was going to be a false thing? Oh, it's not 5. Too bad. Okay. Probably makes more sense. Just, it doesn't really matter, but it probably makes more sense to change the value of num. You see, if it's false, oh, it's not 5. Too bad, right? Okay. So you see, you can put whatever you want inside these curly brackets, multiple lines. I separated them out on separate lines for ease of reference. What matters is the semicolons. All right. If there's other operators to test whether something's true or false, not just equal. You can also do like a less than or a not equal to show you where all these operators are. If you just go to MathPiper docs and then under procedures, operators, and you can see them all. Okay, so like you see less than is the less than question mark. Is not equal, exclamation mark, equals question mark. That's, these are your different operators. You don't need to memorize them. They're here for you in the documentation. All right. So the next thing I want to show you, the last kind of category of subjects that I want to show you are loops. These are good if you want a program to repeat a task. So let's start with a while loop. The way you write it, it's kind of similar to how these if-then statements we just saw are written, but it's going to just continue to loop, continue to go and go and go while something is true. So say, let's just delete everything. Say we have inside our fold here a variable num walrus 3. Okay, so 3 is assigned to the variable num. Excuse me. You can type while num is less than 10. Okay, remember the less than we saw in our operators earlier? Okay, no semicolon yet. So remember, this is the predicate. This is asking while this statement is true, while our number is less than 10, while that's true, no semicolon yet, curly bracket. Okay, so you have your predicate, while this is true, and then what you want to happen while it's true. Okay, while this is true, let's do uh, echo. And again, the lines, I'm just separating them out so it's easier to see. You can make this all on the same line. It'll work just as well. Echo, your number is num. Okay. And then let's do num equals num plus 3. And then well, we'll close the curly bracket and we'll do one last semicolon. We can just, it doesn't really matter. One last semicolon to close out our whole expression here. So what is this saying? This is saying while this statement is true, while num is less than 10, it is true right now, it's 3, okay? We're going to print out this statement, your number is, and then whatever our number is, we'll print it out. And then we'll reassign a new variable to num, and we'll make it num plus 3, whatever it was plus 3. So it's going to be 6, okay, then it'll be 9, and then it'll be over 10, so it we'll see what happens. Okay, so you see, now the result is 12, right? Which makes sense if you think about it, because we have 3 is what our number is. So while it's less than 10, your number is 3. And then it took it. 3 plus 3 is 6. Okay. 6 is less than 10. So it ran, your number is 6. Okay. Then 6, 6, 7, 8, 9. Okay. Now it's 9. Looped back while 9 is less than 10. Okay. That's true. Oops. Your number is 9. Printed it out. 9, 10, 11, 12. Now, your while num is less than 10, no longer true, it's false, so it stopped. It did not print out the next one, though it did tell you what the result is. That's just your general output. So that's it. Then that's how a while loop works. You just do while whatever predicate you want. You're testing whether it's true, and then what you want to do while it's true. Just a word to the wise: make sure you include some way that your while loop is eventually going to end. Otherwise, it's going to keep going forever, and then you'll need to hit this big red X to stop it. Okay, and that can be a big pain. All right, so that's a while loop. It's just going to keep going forever until the predicate is no longer true. A different kind of loop is called a ForEach loop, and that'll just work on each element of a list that you provide. So let's do that. So say you have for each, capital F, capital E, for each. And then within here, you provide some variable, traditionally a lowercase I. It doesn't have to be, but that's what you'll see most often. And then a list of some data. So let's do, 5 to negative 19, 40, or whatever. Okay, some list of data. All right. So this is saying for each element, that's the I, in this list, okay, that's what's coming up here. Well, that's the list for each element. You're going to do something to it. And it's the same format as before. You don't do a semicolon. You do a curly bracket. Whatever, whatever it is you want to do. Whatever you want to do to each of these. So let's do a couple. Let's do echo each element cubed is, and then I, okay, because that's the element I, to the power of 3. And then let's do another one. Echo, each element times 3 is, and then I times 3. And you can just keep doing more and more of these, right? Because you can do as many as you want, but that should suffice for now. And then, end it with your curly brackets and your semicolon. Again, it can be on different lines. It can be on the same line. Just make sure you have a curly bracket, you have a semicolon, run it. Now, each element cubed is 125, okay? Each element times 3 is 15. Okay, so what's this do? Well, it's saying it's going through each element. Yeah, actually my wording here doesn't make sense. Let's do like this element so it makes more sense. Okay, so, it takes the first one, 5, 5 to the power of 3 is 125, and then 5 times 3 is 15. It just took it and it ran it over each and every one of them. So it did it for 5, then it did it for 2, then it did it for -19, then finally it did it for 40, okay? And then it stopped because it's out. It's over. Okay, so you see how it just ran it. It iterated over this entire list. And once it's done with the list, it's done. And speaking of done, that is our last topic, so that just about does it for this introductory tutorial on MathPiper. I hope it was helpful. If you got value out of this, please do leave a like, and I want to wish you the best of luck using MathPiper. It's a pretty good IDE and interface, and I know some schools and some classes have been using it, so hopefully, if you're in class, good luck with class, and thanks very much for watching.